Electrical repair. Why proper diagnosis matters more than guessing. Modern vehicles are no longer simple mechanical machines. They are electrical, mechanical, digital, and computerized systems all working together. The engine, transmission, lights, battery, starter, alternator, dashboard, sensors, safety systems, climate control, power windows, locks, cameras, and warning lights all depend on electricity flowing correctly through the vehicle. That means car electrical repair is not something that should be guessed at. And not only should it not be guessed at, it's really hard to do. It's really hard to do. When a vehicle has an electrical problem, the symptoms can be misleading. A dead battery may not actually mean the battery is the problem. A warning light may not mean the part named in the trouble code has failed. A no start condition may not automatically mean the starter is bad. Flickering lights may not, may simply be a bulb, may not be simply a bulb problem. A vehicle that stalls, hesitates, or acts strangely may have electrical issues hiding behind what looks like a fuel, ignition, or computer problem. That is why proper electrical diagnosis matters. A customer first auto repair shop does not start by throwing parts at a vehicle. It starts by listening, testing, verifying, and explaining. The goal is not to sell the customer something they may or may not need. The goal is to find the real cause of the problem, explain it clearly, and help the customer make the right decision for safety, reliability, and long-term vehicle health. And that is what truly having the customer's best interest at heart looks like. Why vehicle electrical systems are so important. The electrical system is one of the most important systems of any modern-day car, truck, SUV, or hybrid vehicle. Without a strong electrical system, the vehicle may not start, charge, communicate, shift, brake, light the road, control emissions, or operate safely correctly. The battery provides the power needed to start the vehicle and support the electrical functions when the engine is off. The alternator recharges the battery and supplies power while the engine is running. The starter uses electrical current to crank the engine. Fuses, relays, wiring, switches, connectors, modules, and ground move power through the vehicle. That may sound simple, but the system is far more complicated than most drivers realize. So think about this for a second. You have so many different control modules in your vehicle, it's not even funny. And these modules, they talk to each other constantly. So you got 20, 30, 40, 50, 60, 70, 80, 90, 100 modules in a vehicle nowadays, depending on what kind of vehicle you're driving. And these modules are actual computers. You've got them for your transmission, you've got them for your anti-lock brake system, you've got them for the engine itself, you've got them for lane control, you've got them for so many different things, it's not even funny. So all of these modules are talking to each other. They're talking to each other through the wiring system. And most vehicles have over 3 miles of wire in the vehicle itself. Think about it, 3 miles. When was the last time you walked a mile? How long did it take you to walk that mile? 15, 20 minutes is a really, stiff pace on walking on a mile. So what takes you, an hour to walk 3 miles? That's how much wire is in your vehicle. Think about that for a second. And it's behind things. It's under the dash. It's behind the protective, layers that they put it in to protect it from heat and make it to where you can't see it because, nobody wants to see unsightly wires running around and hanging loose and catching on stuff. So they gotta put behind stuff. They gotta keep it out of the way, and they gotta keep it, the electricity running through it. And it's in your trunk, it's under your seats, it's under your dash. So think about trying to actually diagnose electrical. Is it the part itself? And the part itself may be testing good right now, but that doesn't mean the part maybe that is good all the time. And think about it. If you're working on your desktop or your laptop computer, it's not moving. So your laptop, it actually moves, right? I mean, you're not moving it while you're using it, but you definitely can bounce it around going from here, like on an airplane ride or whatever, going from point A to point B, going to the office and back, whatever. But you're very careful with it. You're very careful with it. The vehicle itself, that your vehicle, it's got all of these computers inside of it, is bouncing down the road. You're hitting curves with it. You're hitting potholes with it. You're going over speed bumps. It's the temperature is hot. The temperature is cold. I mean, you protect your laptop. You're not going to leave it sitting in your vehicle overnight in the freezing cold. You're not going to leave it sitting in your vehicle. Think about this: sitting in your vehicle. You're not going to leave your laptop sitting in a vehicle when it's over 100 degrees. I mean, that's a great way to ruin your laptop, and you just wasted so much money. It's not even funny. Well, you got multiple computers in your car sitting in the sun that you wouldn't leave your laptop in. But we don't have a choice, obviously. We leave all of those computers and they're under the dash, a bunch of them, okay, under your seat. And so they're sitting in that super hot car, that super cold car, and we don't think anything of it. And we think that it should just continue to work. I mean, it's pretty miraculous that our cars work as good as they do and perform the way that they perform when we're thinking about the electrical that way. I mean, so the electrical not only is electrical as far as starter and alternator and stuff like that, ignition switch, it's literally electrical. And so then we go into electronic and the onboard computer system. And being able to follow a wiring diagram. If you've ever seen a wiring diagram, I wish I had a picture of one right now. Talk about a convoluted mess. The first time I saw one, I'm like, okay, good luck. You're supposed to follow a wiring diagram on a piece of paper or on your computer screen, and it has no representation in the actual car itself for real. You gotta just get really good at it. And it takes a long time to get really good at it. It takes so much effort and time and focus and energy to start following wires in a car. And think about all the stuff you have to take apart to continue to follow the wire. And yet, automotive repair shops shouldn't get paid for that, right? I mean, working on your up in your attic on your HVAC system, yeah, it can be hot and cold. I'm not saying it's not. It's in your attic, so you're in the insulation and all the other stuff. I mean, it's nasty by itself, but it's just one system. It's a heater or an air conditioner. It's just it's two systems max. If they got the heater and the air conditioner separated. I mean, you got three wires running through your house. I mean, there's probably more there's more the length of wire more in a car than in your house. Think about that for a second. I've never looked it up, but I mean, 3 miles of wire in your car, that's pretty huge. Track down a good automotive repair shop, learn to trust them, let them learn to trust you, build a great relationship with them. A good automotive repair shop is really just, I mean, it's the hardest thing to find, and it's so rewarding once you do. And that shop is so rewarded with a good customer that understands that their expertise should be appreciated and should be paid for. Stay safe, stay strong.